Hello students, welcome again to my channel DNA.12 Education. Today our topic is quadratic sequence. Once again, quadratic sequence. Okay students, what is quadratic sequence in mathematics? Okay, now we're going to discuss about quadratic sequence. A given sequence is a quadratic sequence if the second difference is a constant. Okay, students, look at this example. We have a sequence 5, 12, 25, 44, and so on and so on. Once again, 5, 12, 25, 44, and so on. Okay, students, what is the characteristic of this sequence? Okay, the first is we are going to take a look about first difference. The difference of 5 to 12, we got 7. Why? Because 12 minus 5. And then the difference to 12 to 25, we got 13. Because 25 minus 12. And 25 to 244, we got 19. Okay, students, now we go to the second difference. To the second difference means we're going to subtract the first term to the second term from first difference. Okay, 7 to 13. We got the difference is 6. Why? Because 13 minus 7. And the next difference is 13 to 19. We got the difference is 6 as well. Okay, what's the conclusion, students? It is shown that the second difference is a constant. Once again, it is shown that the second difference is a constant. This sequence like this, we call that quadratic sequence. Why? The second difference is a constant. Is it clear, everyone? Okay. Next, quadratic sequence form. The nth term of the quadratic sequence will be of the form Tn equals to an squared plus bn plus c. Once again, the quadratic sequence form Tn equals to an squared plus bn plus c. Okay, students, take a look to the sequence like this. 5, 12, 25, 44. Once again, 5, 12, 25, and 44. Okay, students, for 5, we can say that n equals 1. So we call this one the first term or T1. Okay, what about 12? For 12, we can say that n equals to 2, and we call this T2 or the second term. Next, 25. For 25, we call that n equals 3, and we can say this third term or T3. And the last is for 44, we can say that n equals to 4, and we call this T4. Is it clear, everyone? Okay, for this quadratic sequence, 5, 12, 25, and 44. For T1 or n equals to 1, based on the formula Tn equals to an squared plus bn plus c, we can substitute n equals to 1 to the formula. We got a times 1 squared plus b times 1 plus c. Okay, we got the simplest one, a plus b plus c. Okay, what about T2? For T2 means a times 2 squared plus b times 2 plus c. We got 4a plus 2b plus c. Very easy, right? Okay, now we go to n equals to 3. For the third term, T3 equals to a times 3 squared plus b times 3 plus c. We got 9a plus 3b plus c. With the same way or the same method, for the fourth term, n equals to 4, for Tn equals to an squared plus bn plus c, we got, for the fourth term, 16a plus 4b plus c. Is it clear, everyone? Okay, we are going to continue the explanation about the quadratic sequence form. Okay, the n term of the quadratic sequence will be of the form Tn equals to an squared plus bn plus c. Tn equals to an squared plus bn plus c. From this sequence, 5, 12, 24, and 44, we got already, for the first term, is a plus b plus c. For the second term, 4a plus 2b plus c. For the third term is 9a plus 3b plus c. And for the fourth term, 16a plus 4b plus c. Is it clear, everyone? To find this equation, so you just insert n equals to 1 to formula an squared plus bn plus c. We got a plus b plus c. For the second term, we can insert n equals 2 to formula an squared plus bn plus c. And we got 4a plus 2b plus c. And for the third term as well, n equals 3, we can insert to the formula an squared plus bn plus c. We got 9a plus 3b plus c. And for the last term, for the fourth term, we got 16a plus 4b plus c. Very clear, right? Okay, students, now we go to the next topic. What about first difference? For the first difference, when I mentioned before that, the first difference we got from the first term to the next term by subtraction, right? By using subtraction method, we got 5 to 12. We got the first difference is 7, right? Because 12 minus 5. Okay, with the same way to the equation a plus b plus c, and for a plus 2b plus c, we can take the subtraction as well. We got, yes, 3a plus b. How you know that? How you know that? That's very easy. First difference means we're going to subtract the first term to the second term. Means 4a plus 2b plus c minus a plus b plus c. So that's why we got 3a plus b. Okay, students, now we go to 12 and 25. So the difference is 25 minus 12. We got 13, that's right. Okay, so what about the equation? Yes, with the same way we can find that 9a plus 3b plus c minus 4a plus 2b plus c, right? So we found 5a plus b. You can prove it, students. Very easy. And what about 25 to 44? Yes, that's very easy. The difference 25 to 44, we got 19. That's right. So what about the equation? Yes, 16a plus 4b plus c minus 9a plus 3b plus c. We got the equation 7a plus b. Very easy, right? Okay, students, now we go to the second difference because this is the characteristic of the quadratic sequence form. Students, we go to the second difference. The second difference means we are going to find difference from the first difference. Okay, students, 7 to 13. The difference is 13 minus 7. We got 6. So what about the equation? Yes, 5a plus b minus 3a plus b. Right? We got the second difference of the equation is 2a. Right? Okay, what about 13 to 19? Yes, the second difference from 13 to 19 is 6 because 19 minus 13. Right? So what about the equation? Yes, the equation is 7a plus b minus 5a plus b. We got 2a. Right? Wow. What is the characteristic of quadratic sequence form already found? Okay, here we are. Right? Once again, this one, right? So what is the conclusion? Yes, correct. This is the conclusion of the quadratic sequence form. For the first term or T1, we can say that for T1 equals to A plus B plus C. Once again, T1 equals to A plus B plus C. Next, for the first difference equals to 3A plus B. Once again, first difference is 3A plus B. And the last conclusion, we call that second difference equals to 2A. Once again, second difference is 2A. We can say this one, this is the keyword of the quadratic sequence form. Very easy, right, student? Okay, students, now we're going to the last final of the solution quadratic sequence of the example 1. Okay, the quadratic sequence is 5, 12, 25, and 44. Now we're going to finalize this quadratic sequence formula. Okay, for the first difference, we got already. For 5 to 12 is 7. Next, 12, 25 is 13. And 25 to 44, we got 16. Okay, now we go to the second difference. For the second difference, we got 7 to 13. We got 6. And 13 to 19, we got the second difference is 6 as well, right? Okay, based on the conclusion, we got that the first term, or T1, we call that A plus B plus C. The first difference, we got 3A plus B. And the second difference, we got 2A. Is it right, everyone? Okay, from this quadratic sequence, we got that 6 is the second difference. The second difference is formulated as 2A. So we can say that 2A equals to 6. And A is 3. That's right, everyone? Next, now we go to the first difference. Yes, the first difference is 7. Based on the conclusion, we found that the first difference is 3A plus B. Means 3A plus B equals to 7. Students, we can insert A equals to 3 to this equation. So we got 3 times 3 plus B equals to 7. And we got B equals to minus 2. So what's the next, students? Yes, we go to the first term. The first term is 5. That's right, students? Yes, the first term is 5. Based on the conclusion, the first term is A plus B plus C. So we can say this, A plus B plus C equals to 5. Okay, we can substitute B equals to minus 2 and A equals to 3 to this equation. So we got 3 plus minus 2 plus C equals to 5. And finally, we got C equals to 4. Very simple, right? Okay, the formula of Tn of the quadratic sequence is an squared plus bn plus c. That's right. So this formula will be satisfied by, yes, Tn equals to 3n squared minus 2n plus 4. Once again, 3n squared minus 2n plus 4. That's very easy, students? Yes, I agree with you. Thank you very much for watching this video, and bye-bye.